All right. We're going to start a series here for grade 8 and 9, and we'll be looking at natural and whole numbers to begin with. And this is the first of many quick, short questions that we'll be answering. And hopefully, as grade 8s and 9s follow along, they'll be able to learn some valuable concepts which will help them in their foundational knowledge and understanding. So, tune into more sessions and tune into more us getting to answer a few questions. And so, my amazing maths gamers, the first question that we have there says find the sum of the first 5 whole numbers. Now, in order to be able to answer this question, we need to understand some terminology. So, first and foremost, we are told to find the sum. Now, what does the word sum mean? Now, for those who may not know, the word sum means the addition, or in other words, the total. Okay? And addition, total, sum, these are all words that mean the same thing. So if we're asked to find the sum of, it means we need to add the following numbers. It says the sum of the first 5. Okay? First 5 what? Whole numbers. What are whole numbers? Whole numbers are numbers that start at 0, increase by 1, all the way to infinity. And by that I mean these are numbers that start at 0, like 0, 1, 2, 3, 4. And by infinity, I mean that these numbers go on and on and on. There is no foreseeable end. We can go on and on. But they want us to find the what? The sum. Sum means addition of the first 5 whole numbers. The first 5 whole numbers would be 0, that's our first one. 1 would be the second one. 2 would be the third. 3 would be the fourth. 4 would be the fifth. So they want us to find the sum. So that means 0 plus 1 plus 2 plus 3 plus 4. Now what does that give us? 0 plus 1 is 1, plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10. Alright, so by me showing this plus indicates that I understood what the word sum means. And then the first 5 whole numbers, writing down the addition of the 1, 2, 3, 4, 5, starting from 0, of course, because those are the first 5 whole numbers. There they are, 1, 2, 3, 4, 5. So these are really truly the first 5 whole numbers, and that is their sum. The sum is 10. The total of these numbers, the first 5 whole numbers, is 10. So let's grasp this way of being able to approach these questions by first really truly understanding how important it is for our learners to be able to comprehend and be able to unpack mathematical concepts like sum. Sum means the addition, the total of the what? The first 5 whole numbers. We've been able to accurately answer that question. Let's move on to the next question. The second question says, find the product of the first 3 prime numbers. So once again, what do these terms mean? Find the product. What does the word product mean? This means the multiplication of, all right, the first 3 what? First 3 what? Prime numbers. What are prime numbers? Prime numbers are numbers that have only 2 factors. In other words, they are divisible by 2 numbers. Okay, and these numbers are 1 and that particular number that you are referring to. Okay, numbers that have 2 factors, 1 and itself. So these prime numbers are numbers like 2, 3, 5, 7. Why? Because 2 has only 2 factors, 1 and 2. In other words, 2 is divisible by 1 and it's divisible by 2 and it leaves no remainder. Basically, there's no other number that 2 is divisible by. That is a natural number. So 3 also has only 2 factors, 1 and 3. 5 has only 2 factors, 1 and 5. 7 has only 2 factors, 1 and 7. We do not say that 1 is a prime number because 1 in and of itself is not a prime number. So it says find the product of the first three prime numbers. Product means multiplication. That is the mathematical symbol that we use for product. The prime numbers, the first 3 prime numbers are 2, 3, 5. So what do we do? 2, 3, 5. Then product. So that means what's 2 times 3? It's 6. What's 6 times 5? It's 30. So indeed, we have been able to answer that question successfully. And if they are allocating 3 marks for this question, then basically being able to represent the 3 numbers would be 1 mark. Being able to then identify the product would be another mark. And then being able to get the answer, the product in and of itself, which is 30, would be another mark. So very well answered. Just like with this previous question, find the sum of the first 5 whole numbers. Basically, they gave us 2 mark allocation there, and that's according to the liberty of the person who's basically setting the question. It basically means we allocate 2 marks, of course. Then the very last question that we'll do for today is write down 2 numbers that are factors of 18 as well as perfect squares. Now, let's unpack the question. Write down 2 numbers that are what? Factors. What are factors? Factors are numbers that go into another number without leaving a remainder. Okay, so those are numbers that are basically that go into the other number. Okay, we say they are divisible. Okay, so 18 says write down 2 numbers that are factors of 18 as well as perfect squares. So let's first write down the factors of 18. Numbers that go into 18. Let's list them. So first and foremost, we start with the first natural number. Natural numbers are numbers that start at 1, increased by 1, all the way to infinity. So let's basically survey all of our natural numbers and check. 1. Does 1 go into 18? Yes, it does. How many times? Now, I like actually writing the number that complements, or basically is the number that is a product which will give us 18. So 1 goes into 18 how many times? 18 times. So we write down 18 because it is surely the last number that is a factor of 18. Then let's progress in our natural numbers. The next number after 1 is 2. Does 2 go into 18? Well, we can check. 2, 4, 6, 8, 10, 12, 6, 14, 16, 18. So yes, it does go. How many times? 9 times. 2 goes into 18 how many times? 9 times. So there we have it. Then let's check. 3. Does 3 go into 18? It seems like it does. How many times? So we ask ourselves, how many times does 3 go into 18? Or we could simply say, what is 18 divided by 3? 18 divided by 3 is 6. All right. Then we can check 4. Does 4 go into 18 without leaving a remainder? 4 goes into 18. Nah, 4 doesn't go into 18 without leaving a remainder. So that means it's not a factor. 5 as well doesn't go into 18 without leaving a remainder. 6, we already have 6. So that means that is all of our numbers that go into 18. Now, it says, write down 2 numbers that are factors of 18. So we have them, there they are. But then it says, as well as perfect squares. So from these numbers, we need to identify the numbers that are perfect squares. What are perfect squares? Perfect squares are simply numbers that we are able to get by taking a certain natural number and multiplying it by itself. So for instance, 1 times 1 gives us 1. That means 1 is a perfect square. I just use the word PS to show that it's a perfect for P, square for S. Okay, if we take the next natural number and we multiply by itself, we get the number 4. So P4 is also a perfect square. So these are perfect squares. So let's just check here. Which numbers here are perfect squares? 1 is a perfect square, 2 is not, 3 is not, 6 is not. 9 is a perfect square, because remember 3 times 3 gives us 9. So that means 9 is a perfect square. So all in all, our answer would be 1 and 9. This is basically our answer. Okay, but in order to have been able to get to this answer, it was important for us to be able to first write down what the factors of 18 are, so that from that family of factors we can identify the perfect square numbers that are basically represented, which are factors of 18 as well. Okay, right, 3 beautiful questions, and guys, we'll tackle others tomorrow. So my grade 8s and 9s, I hope this video was helpful and that you will basically look forward to the next video as we revise and look back on the term 1 work which you were supposed to have mastered.